Now, building up from the chirality video, we can determine the absolute configuration using the spatial conformation of the bonds of the chiral centers, and by identifying the increasing and decreasing order of the molar mass of these groups. So, how do you do that? First of all, I colored the different carbons with the different chiral centers with different colors, so it'll be easier to see. Now, we need to check from the periodic table the different molar masses. In the red carbon, you have Br as the biggest one, then you have Cl, then you have two carbons, so I need to find out what these carbons are connected to, and you have this other carbon which is connected to I, F, H, and notice I put them in decreasing order of the molecular weight. Now, immediately while looking at the first substituent, you're going to find out that this carbon, the blue carbon, which is a substituent for the red carbon, which is a whole group, is going to be bigger. So this would be considered as 3, and this would be considered as 4. Remember, we're only talking about this carbon right now. Now, if we are going to look from the position of the blue carbon, the blue chiral center, you're going to notice that this is 1, okay, then this is 2, this is 3, and this is 4. Now, to identify the absolute configuration, it's very simple. You just need to check whether the fourth group is wedged or dashed, which is this line right here, and to check whether the groups are clockwise or anti-clockwise, and they go hand in hand. It's quite easy. It just needs a little bit of memorization. So, first of all, let's look at the red chiral center, and we only need to look at 1, 2, 3. We don't need to count 4. Now, I know some of you would say that 4 is outside of the order in this case. If you look at 4 right here, you would say that it's out of the order, okay? So it goes 1, 2, 4, 3, but I don't care about 4. 4 is going to determine whether this is S or R, okay? So I'm going to check 1, 2, 3. Now 1, 2, 3, they're going in this direction, 1, 2, and 3, okay? So is this clockwise or anti-clockwise? This is anti-clockwise. So for the red carbon, you would say anti-clockwise, and you look at the fourth group. Is the fourth group wedged or is it dashed? It's wedged. So wedge on 4, which would mean that usually if it's not a wedge, if it's just dashed and you would say it's anti-clockwise, then it will be S. But since it's anti-clockwise and it's a wedge, you need to flip it. So usually under normal circumstances, if you have a dash and clockwise, it's going to be R. If it's dashed and counterclockwise, it'll be S. If it's a wedge clockwise, it'll be S. If it's a wedge and counterclockwise, it'll be R, okay? So anti-clockwise plus a wedge, it's going to be, in this case, R. Now for the blue one, same thing. We count 1, 2, and 3, okay? So in this case, it's going clockwise. So clockwise plus on 4, which would mean that this is R.